Alright, so today is related rates, and do not mind the rain. It's a change scenery I had to make. So for this one, it actually has to be a application problem. So in this case, I chose this problem right here. Yeah, this one right here. Man 6 feet tall is walking away from the spotlight located on the ground. His shadow is cast on a wall 40 feet from the spotlight. If the man is walking at a rate of 4 feet per second away from the spotlight, determine the rate of change of the shadow when he is halfway to the wall. So from the main work problem, we get two values which are required. So the way that differential rates work is that we have to have x and y on the same side. So in this case, it's going to be yeah. I'll just work with it as I go. So right now we have two things. When he is halfway to the wall, that is x. So we get x is equal to 20, and then we have the rate of change for x, which is 4 feet per second. So from that we get this. Now you're going to notice that the value of this, or the variable used, is dx over dt, because the way that these rates work is that it's a differential in reference to time, or t. So we end up with x is 20 and the rate of change being 4 feet per second. So right now we're going to want to set up most of the equation. So what we end up doing is x is equal to x over 6, because that's the height of the man, and then 40 is the distance between the wall and the spotlight. X in this case would be the distance between the spotlight and the man. Y would be the height of the shadow. So we end up with the whole proportion using a cross multiply. We end up with x times y is equal to 240. So from here we're going to have to do a bit of derivatives. So from the way it works is, in this case we have d of x over dt, which is this thing right here, multiplied by y. It's basically a product rule. So in this case, we have x is derived to dx over dt, and y is derived as dy over dt. So that's basically like this is like the derivative of f, and this is the derivative of g. So product rule states this would end up being our new equation to work with. So dx over dt times y plus dy over dt times x equals 0. So from here we have 2, but we're looking for 1 out of the 4. We only have 2, so we should probably look for this, because that's going to be easier than finding this. So I have the math already done off to the side. So going back to the original cross multiplication that we had here, x over 6 is equal to 40 over y. We plug in the value of x, which, as we stated earlier, was 20. So 20 over 6 equal to 40 over y. Cross multiply, 20y equals 240. Both divided by 20 equals 12. So plug everything in. It's 4 times 12 plus dy over dt times 20. So you want to get the value of this part right here over here, which ends up being a negative 48. Divide both sides by 20. We end up with dy over dt is equal to negative 12 over 5 feet per second. And you're going to want to actually state that. You actually have to write this down. So the rate, when you end up saying that the rate of change decreases at a rate of that the answer we have. So negative 12.05 feet per second when, in this case, you could either use the terminology used in the problem or the algebraic terms. So when either x is equal to 20, and this can be one statement. There we go. This can be a statement in itself. Okay, here we go. So this can be a statement in itself, but there's also another way, which is basically everything except after here, you have instead when, when the man is halfway to the wall. And this is a totally different option altogether too. But both answers are correct. And that's all derivatives.